Hi there, this is Abhishek, and in this video we will go through some of the coding related to the market basket analysis. So in my previous video I have talked about the theory related to the market basket analysis, about what it is, what are the three different parameters or three different controls that you really need to look at to tune your market basket analysis or understand how you can get better results from your market basket analysis. So if you have not watched that video, I would really recommend, because that is a base or foundation to understand in which situation you can use the market basket analysis and what are the different parameters or controls related to the market basket analysis, which is what we will going to use it here in the coding. So we will use the library or the package, which is arules, and it's basically having the appropriate algorithm which is useful or needed to do the market basket analysis. Similarly, we will use another library which is arulesviz, which is a visualization, whatever rules that we are getting. If we want to report it, as you know, visualization form is very helpful. So to visualize those rules, we will going to use the arulesviz library. So if I hit enter, it will load all of those packages. If it gives warning, no worries, because it may be because, as it's saying, arulesviz was built under version 3.3.3, whereas I may be using some other version of it. So it is just giving me the warning. All right. So what do we need to do after that? After that, we need a data set to work on. So if you know the data set, or if you already have the data set related to your company, then you can use it. Otherwise, you can use built-in data set which comes with the arules package, and it is nothing but groceries. So this is the data set groceries, which is saying that the groceries dataset contains 1 month or 30 days of real world point of sales transaction data from a typical grocery outlet. So this is just the data related to the grocery outlet, what are the items that they have sold, and it is basically for the 1 month. So as you can see, it is not a normal data set. It is basically a transaction data set. So that's an important thing, that to process the rules by the arules library, you cannot use a normal data frame, but this needs to be converted into a transaction data set. So if I see the structure of groceries data set, you will see that it is a formal class of transaction package, and these are the different data items that it is showing, not very similar to how you usually see in a data frame. So if you want to see some elements or all the elements related to the groceries, you can use the command which is inspect and then give the name of the data set or the transaction data set, which is groceries. So it has a lot of items, like 9835 items, and as you can see, with each row ID it is, or the transaction ID, it is having its bucket. So this is the bucket you can consider like your basket which you have in the grocery market, and these are the items that you have put in your bucket. So chicken, tropical fruit, other vegetables. So these are like shopping product categories that you have put in your or the products that you have put in your basket. So groceries, as you can see, this groceries data set that we evaluated earlier is basically an inbuilt one. But what happens if you have the data in CSV or something? Well, in that case, what you can do is you can use the command which is read.transactions and then give a file. So by default it will be a basket, so you don't need to really worry about it, but just simply go ahead and give the name of the file, the location, and if you don't know how to give it, you can use the command which is file.choose. Once I hit enter, it will open up the proper box in Windows, or the open box in Windows, and I can just go ahead and choose my groceries, which is now in this case in a CSV format. Since I already have it, I will not go ahead and use it, but you can use this read.transaction command, and with the help of read.transaction, store it in a groceries object or any other name which you want to give it to your object. Alright, now let's go ahead and see how you can process the rules. So to get the rules, we will use the algorithm which is in the A-rules package, and the name of the algorithm is appropriate. So if I put a question mark and then go ahead and get the information about appropriate algorithm, so it's basically saying it's a mining association and mining frequent item dataset association rules and all. So that's what we are going to use. It is simply asking about the data and the parameters, and let's go ahead down and see the parameters, like how you can specify. So this is the data set they have given an example, and these are the parameters, like what is the support, confidence, and target is basically they are specifying here in this case. So main thing is about support and confidence. What level of support or confidence you want to use? Well, you can play around with this and see the rules that you are getting. So here in this case, let's specify some of the groceries underscore rules, or maybe gr underscore rules. It's like a long one, I have to write it again and again. Gr underscore rules and appropriate algorithm, and we specify the groceries dataset. So this is the minimum requirement of the algorithm that you specify. Once I hit suppose enter, it says that appropriate parameter specification. So as you can see, I have not done anything. I have just specified the dataset name, but by default it has chosen that confidence is 80%, and there will be the support for it, and here it is 0.1. So by default this is what it has identified or given us the result back to us. But if we want, we can specify whatever our requirement is. So we can say parameter, and within the list we are saying support is equals to earlier, let's say it has using 0.1. maybe in our case, because our data set is really lengthy, so 0.1 what it indicates, so if you remember from my theory video, 0.1 indicates that you are looking for a transaction which has at least happened 10% of time. Here in this case, that is what you are specifying. So sometimes in a bigger data set that's not the case, and maybe you are just looking at those products which are together at least 1%. So here in this case, maybe you can specify 0.01 as a support, and confidence. So confidence, if you see CONF, confidence is equals to here in this case 0.8. If you're really looking for some good rules with high confidence, you can specify 0.9 like it has specified over here, or if you want to evaluate more rules, then you can specify 0.7, which is like you want a confidence of 70% in this case. So let's keep it 0.8% because I think that's a good parameter. 80% seems like a good parameter or a confidence to look at. So once I hit enter, again it has given us the parameter specification about confidence interval, the support. There are a couple of others which is what you can tune when you are really an expert. But if you're a beginner, that's the two things you should really look at and see what or how you can tune and understand and get the right results. Alright, once you have understand or once you have done this thing, this is the time to look at the rules. So we will use the inspect, which we earlier used, inspect gr underscore rules, and let's say we want to see the first 5 or the top 5 rules. So once I hit enter, so in this case what has really happened, the issue that you have got is basically because of you have no rule. And that will be surprising to you that, okay, you have run the algorithm and you have set the parameters, but you have not got any rule. Well, that happens because probably you need to further fine tune the parameter. And maybe it is because, let's say, you have specified maybe high confidence or high support level, and that's why you have no rule. So let's fine tune a little bit more with the help of these parameters. So we will look at the previously executed command by using the up arrow from your keyboard. And in this case, let's increase the support level over here and then hit enter. So once I little bit decrease the support level, so earlier it was 1%, now it is 0.1%. Well, and then what has happened that you have got 410 rules. So let's say now if you want to use the previously executed command where you have got subscripts bound of error, subscripts out of bounds error, you will, if you use or execute it again, what you get is some of the rules. So as you can see, earlier you got an error, you fine-tuned some of the parameters by decreasing the support or confidence, and you got the rules out here. So these are the top five rules which you have got. If I just here in this case decrease it a little bit. Yep. So what it is basically saying that this is the left hand side and this is the right hand side. And reading it is also very simple, that if any customer who has bought butter or jam, they have bought whole milk, or a person who have bought, or customer who have bought liquor and red or blush wine, they have bought a bottled beer also. As you can see, the confidence is high and lift is also very, very high. And as we have seen in the previous video about when the lift is greater than 1, it is generally a good rule to consider for, and if it is less than 1, it is not a good rule to consider for. So as you can see, all of these rules are above 1. So let's say we want to get maybe 10 rules, so you go and get the 10 rules information, and even after that, the lift that you get in almost these cases is high. Well, that happens because some rules are really, really obvious. You already know about that and you don't get any new learning from it. So for example, curd and cereals, whole milk, obviously somebody who will buy curd and cereal, that's general assumption they will be buying the whole milk also to use it with the cereal. Same is with the butter, jam, whole milk, very, very obvious information. But some rules are a little bit trivial. For example, napkin and housekeeping products and then whole milk. You don't really understand. Maybe it's like with all the housekeeping, all the products somebody is buying, they're also buying the whole milk. That's the general assumption that you can get. Or maybe with soup and bottled beer, they are buying the whole milk. Or maybe whole milk in that particular area or in that particular state or maybe city, it is like, very consumable product, or people are really, really healthy and most of the people are really going and buying the milk almost most of the time, and that's why we are seeing whole milk over here. So that's kind of the observations or the rules that you have got, and you really need to evaluate the rules about what each one is saying, or maybe look at most important ones here in this case, as we are looking at the top 10 rules, and make your actionable or trivial rules accordingly and report on it. Sometimes you are interested in sorting the rules also. So for example, as you can see, currently the rules are sorted by I think here in this case they are not sorted, but they have just given you the top one, because if I see the lift, it is 11 and then 3, but somewhere at observation 9 you have 4. Same is the case with confidence. I don't see they are sorted properly. Even in the case of support 0.191017, so they are not sorted. So if you want to sort it, then how you can do it is basically you again, let's say, use the same object to store the sorted rules and use the sort. What you want to sort is gr underscore rules, and by is equals to whether support or confidence or lift, what do you want basically in that, or the parameter by which you want to sort it. So let's say maybe here in this case we want to do it by support, and we want decreasing true because we want high support to be appeared first. So once I hit that, it executed, and now I want to inspect the top 10 rules, or I just gr underscore rules. All right, so that has come properly. So if I want to do that, these are the rules which are sorted by support, and now in this case the maximum support is coming from here. Here is the confidence related to it, here is the lift related to it. So accordingly you can sort it and get the output. Well, that's one thing, that you can sort it by support, you can sort it by confidence, you can sort it by lift, so that you can get what you are really looking for from the rules. After this, what we generally try to do is identifying the duplicate rules, because it may happen that the rules which is given earlier is also appearing a little bit late, and that's a very general problem that you find it with the market basket analysis. So for that, we will generally identify the redundant rules and remove this. So to identify the duplicate rules, let's use the function within the arules package, which is dot redundant. If you want to know more about it, put a question mark and say is dot redundant, and it will show you. So it provides a generic function as per method redundant to find the redundant rules. All right. Well, there are a couple of other methods. I find it a little bit, they may be efficient or they may be inefficient, but since it is inherent to this, I think it is more efficient as compared to anything else. So I will going to use this, and I will say gr underscore rules. So first of all, let's see how many rules that you have, and then let's find the redundant rules. Redundant underscore rules, and we will say is dot redundant, and the object name where we have all the rules, which is gr underscore rules. So if we see now redundant underscore rules, it shows all of the information about true false. So true indicates that here, let's say here in this case, that it is a duplicate rule. False indicate that it is not a duplicate rule. So if you want a summary, we will say redundant underscore rules. It is showing that there are 18 rules which are duplicate. So how to remove that? Gr underscore rules, and we will say gr underscore rules and not equals to redundant underscore rules. So if we see now gr underscore rules, it is 392 rules. So that's how you can remove the redundant rules from your rules object, whether it is gr underscore rules or any other object that you created. Now let's say how we can target our items. Say for example, if you're really interested that what are all the customers who are buying product X along with other products, or maybe with product X, what are the other products that are getting bought. So it's basically a rule of left hand side and right hand side. So left hand side says that this is what customer bought, and right hand side says what they have bought along with the left hand side items. So what I meant by that is basically, if I go and show you the rules again, gr underscore rules and 1 to 5 maybe here in this case. So left hand side is this, that customer has bought liquor and blush wine, and they have also bought a bottle beer. Now maybe what you are interested to know is what are all the products that are getting bought along with the bottle beer. So maybe you want to change the position of bottle beer from right hand side to left hand side so that it will become a default item. So how to do that? Well, for that gr maybe underscore rules underscore beer. Let's say we want to create a rule that is related to the beer, and we need to again run the appropriate algorithm by giving the data set, which was groceries, and with the parameters let's say here in this case it was list, and confidence was support was 0.001, and confidence was if I remember correctly, it was 0.8. So these were the one that we initially provided. Use the another parameter, which is nothing but appearance. Again, we need to specify the list, and we need to specify what is our default. So default is equals to, in this case, since we want right hand side to be default and left hand side to be, we want bottled beer. So in that case, bottled beer will come over here and its related product will come over here. So it's kind of a opposite direction if you're really interested in looking at it. Let's try identifying what it has got. It has got 0 rule here in this case. So maybe we may need to lower down our confidence here, maybe in this case. So which may be 0.5, and then say again in this case 0 rule. So that means the appearance is really less. So what we can do is, another one was the whole milk is what we have seen. So maybe we can specify the whole milk, because I think that is what getting most of the time, the whole milk option. So if I hit enter, so again it has got almost no rule. 0 rules is what it has identified. If I go back and make it 0.001, all right, in this case also no rules, but again if I make it 0.08, so no rule is, this is what I was looking for. So I have now decreased the confidence a lot. Earlier it was 80%, now I'm saying only 8%, and hit enter. So in this case it has now generated 35 rules. So you can see that you need to play a lot with these parameters, because normally your transaction data set will be huge, and accordingly you need to understand what support and confidence means and get the elements. So inspect, you will going to use, and gr_rules_beer, though we figured it out for whole milk, we'll see for beer also. So inspect rules, and we want 10 rules, and here are our 10 rules. But as you can see on the left hand side, since it was default to whole milk, this is what the items which was bought along with the whole. The next thing is maybe let's say try it out last time with the help of bottled beer. Yeah, in this case it has resulted in 22 rules. So maybe we can run this command again and get these rules. So left hand side we already know that it is a beer, since based on our parameter, and with that you have got pastries, citrus fruit, shopping bags, all of these kind of things. So based on this information you can play around the left hand side and right hand side and make either side default if you want. So here, like this default, we made the right hand side, then we can make left hand side default, which is by default is a default option, and left hand side to or right hand side to be any of the option. So that's how you can play around with this parameters. Next thing is about visualization of rules. So as you remember, we have used the A rules viz package to do that, and now let's see how you can visualize the rules which you have created. So let's use the command plot gr_rules, method is equals to graph, graph, and let's hit enter and see. So because there are a lot of rules, which are 392 rules, that's why you have got this very busy graph. So this is trying to generate in the backend. My processing, the system processing is going on. So let me hit pause for a moment. All right, it has come back, and as you can see, it is really busy, but red blush wine liquor is definitely kind of pretty much out and showing some sort of significance. So how you can make it a little bit interactive is by first of all closing this and then make it a parameter which is interactive and saying interactive is equals to true. So once you hit enter, it will generate the interactive graph here in this case. So it takes a little bit time because it is doing the processing. Let me hit pause again, and here if I show you graph plot, it is kind of producing it over here, which in this case the green ones which is showing is kind of the important or the most frequent one along from the other ones. So I can actually pull it out and make it interactive one based on how I want to see the rules. Liquor, it is showing the connecting one, the connection between bottle beer, this and liquor. Soup, so that's like a multiple connection which is going on. So you can actually play around a lot with the help of this. As you can see, I'm kind of doing it one by one, but the ideal situation is that what you need to do is look at very limited rules like we created for beer or liquor or whole milk, so that you are not getting this cluttered or very busy graph to sort it. So that's about the plotting the visualization rules and making it interactive. But this is just starting, and when you will get these basics very clear and start generating the graph and keep looking the data, you will find a lot of observations and a lot of ways to further enhance it a lot.